Hey guys, so I got a question about the Clausius-Clapeyron equation and how to use it in situations like this. So the question says vapor pressure of ethanol is 115 torr at 34.9 degrees Celsius. Okay. If the change in vapor pressure if the change in enthalpy of vaporization of ethanol is 38.6 kilojoules per mole, calculate the temperature when vapor pressure is 760 torr. So first, let's just write the equation. So this is the Clausius-Clapeyron equation. This is one version of it. It can be rearranged many different ways, but I like this version. You only need to know one version to do it correctly. But in this problem, what we have is the pressure at a certain temperature. So since this is the pressure at this temperature, we're going to call it pressure 1 and temperature 1. And then it gives us the change in enthalpy of vaporization for ethanol. So we're going to plug that in. But the question is also giving us pressure change. It's saying that it goes from 115 torr up to 760 torr. And it wants us to find the temperature when this occurs. So I'm actually not going to solve the problem because I just want to show you guys how to isolate it. I think you guys can do this on your own. It's going to be 79 degrees Celsius. But this is how I like to separate. I don't plug all the numbers in first. I actually rearrange it with the letters and the factors still in it. So what I like to imagine is that this is one entity on its own, and then this is one entity, and this is one entity. Because they are just like three separate things on their own. And so this is C, we can call this A and call this B. So A times B is going to equal C. So if A times B equals C, what we want to do is get the temperature, right? And this is where the temperature is. Well, the first thing we can do is at least get rid of this guy. So we're going to divide by A. So C divided by A. So let's do that. Ln of P2 over P1 over negative change in enthalpy for vaporization of ethanol over R. Okay. And that's going to equal just B by itself, which is this guy. So if that equals 1 over T2 minus 1 over T1, then we only want T2, right? So last thing we have to do is add T1 to this side to get rid of it and then add it on this side. So let me give some space. Plus 1 over T1. If we wanted to find T1, let's say this was not given to us, but T2 was given to us, it would just be the reverse, where we would actually have to get rid of the T2. So it'd be minus 1 over T2, get rid of it, and then put minus 1 over T2. So it just depends on the situation. Right, so plus 1 over T1 is going to equal 1 over T2. And then now, since you're going to have everything on this side, since every single thing that you don't know is given in here, and you can definitely plug it into, it's given in this problem. I mean, not specifically like this, where this arrow is in the problem. So since everything is given to you, you can just plug it into a calculator. I don't do that because there's so much room for error to plug it in all at once. So I like to keep it the way I wrote it below, which is with the C and the A. And I just solve for C separately, and then I write it down on a piece of paper. And then I solve for A separately, I write it down on a piece of paper, and then I divide them. And then I'll just add 1 over T1, and that gives 1 over T2. So it's your choice. And then lastly, what you have to remember is you solve for 1 over T2. So this means that you solve for the upside down version of the temperature. So the last thing you have to do is this. So you can either take what's gonna happen is you're gonna get a number. But since this number is equal to 1 over T2, what you can do is two options. You can raise it to the -1, or you could do 1 over the number. These are the same thing, and they will give you the final answer. So that's it for this video. I hope it was helpful, and I'll see everybody later.